In this first example from the transmission network tools, we will look at PV curves. The project should have study case transmission network tools PV active. The base scenario is used. PV curves are a useful tool for assessing the performance of a network under conditions of increased load, indicating how much the demand can be scaled and where the critical points in the network are. For critical busbars, a plot can then be created of voltage against power. We will first run a load flow to check that there is a valid base case. In this example, automatic tapping of transformers and shunts will not be enabled. Balancing will be by distributed slack on synchronous machines. We now run a load flow. The transmission network tools toolbar should be selected. This button is used to run the PV curves calculation. It is possible to scale loads across the whole network or select a set of loads to be scaled. It is also possible to record results for all busbars or just a selection. In this case, all loads will be scaled and the results for all busbars stored. We press execute to start the calculation. In the output window we can see that the loads have been scaled to about 6,800 megawatts, and the critical busbar is shown. A PV curve can now be plotted using this button. By default, a PV curve is just plotted for the critical busbar. We press execute to create the plot. We can choose instead to plot curves for several busbars. When this option is selected, busbars can be added here. We will select all the busbars in the northeast. Then the curves can be created. Returning to the PV curves calculation, it can be seen that it is also possible to consider contingencies when running the PV analysis. We follow the link to the contingency analysis container, where the contingencies can be specified, in this case all the busbar faults in the northeast. Now the PV curves calculation can be repeated with the contingencies being considered.